All right, ladies and gentlemen, I'm going to be walking you guys through the 3B test review 2. All right, so we'll start with number 1. It says, verify that x plus 3 is a factor. How do we do that? We're going to go ahead and run this through synthetic division. And if the remainder comes out or is equal to 0, then we'll know that it is indeed a factor. If it's anything else other than 0, then it would be no, it's not a factor. So let's do the math. So first, we're going to use the factor that they gave here. So it's x plus 3. Remember, if we set that equal to 0 and then solve, we'll have what we're going to use for this synthetic division. So x is equal to -3. That's our 0. Okay, and so we'll have -3 out here. Then we use our equation to figure out what we're going to put in the slots. I'm sure all of you remember that. If not, here you go. So we'll start here. First thing I look at is to see if this is counting down in order. So 4, next number is not 3, so it's not counting down. So that means we're going to have a placeholder of 0 because the x to the third term is not there. And then the same thing for x to the first, that's also not there. If this constant wasn't there, then that would also be a 0, okay? And so the number out in front of that x to the fourth is an invisible 1. X to the third is not there, so it's a 0. X to the second is there, so we'll put that 9 there. X to the first is not there, so that's a 0. And then our constant is 18. And so we're going to take this through synthetic division. Now remember, first number automatically goes down. Okay? So rule of thumb is if you're doing math on these numbers in here, remember that's addition. If it's down here, you're using multiplication. So this -3 times that 1 is what? That is a -3. And so now that we're dealing with up here, then it says addition. A 0 plus a -3 is a -3. -3 times -3 is a +9. Oh. 9 plus 9 is 18. -3 times -18, or +18 rather, is -54. Combine the 0 and the -54, and you'll have -54. And then, what is that? -3 times -54 is 160. Where is that? That is 162. So remember, our remainder is always going to be under the last term. And so 162 plus 18 is 180. Because this is not equal to 0, it's not a factor. If it was equal to 0, then that would have been a factor, and you would have been done. All right, so let me write. This is the same thing as 0. All right, so let's move on to number 2. So it's now providing you with the x-intercepts. Okay, and I'm sorry, it's giving you the factors. So it wants us to give them the x-intercepts. So that's pretty easy. So let's walk through that. So as you can see here, it's giving us a factor of x, x minus 3, and 2x minus 5. in order to find your x-intercepts, all you do is take all of those factors and set it equal to 0. So there's x is equal to 0. X minus 3 is equal to 0. And 2x minus 5 is equal to 0. Then you just solve. So x is equal to 0. Clearly, it's already solved for x, so x is equal to 0. So there's one x-intercept. Let's look at the next one. So let's circle that. So let's get that 3 off of there. There, x is equal to -3. And then over here, we'll solve for the last one. We have a positive 5 there. Whatever you do on one side has to be done on the other. That cancels out. Gives you 2x is equal to a positive 5. In order to get this off of here, opposite of multiplication is division. Divide that by 2, divide that by 2. X is equal to 5 over 2. And so your x is equal to 0, 3. Well, actually, it should be 3. Let's go back. This should have been a positive 3 over here. Hopefully, you guys caught that mistake early on. So that should be a positive 3. So we'd have 3 down here. And then marking my thing up. Let's try that again. Erase. So 0, 3, and 5 over 2. And we're done. Those are your x-intercepts. So let's drop down and look at number 3. So they're giving us zeros. You have a -3, 5, and 2i. We talked about it in class, but whenever you're dealing with imaginary, imaginary numbers or radicals, remember they come in pairs. So this is giving us a positive 2i. We also know by rule it's also going to give us a negative 2i. Important to know that. So if we were trying to find the factors, so it's asking us what are the factors of the polynomial. Okay, well, pretty much most of us know that you're pretty much just going to put an x in front and change the sign. But let's see why that works, because you want to get the factors to 0. So let's look at the first one. I'll only do the first one. So we're looking at -3. So x is equal to -3. But we need it set equal to 0. So in order to do that, we have to do reverse math. So that's positive 3 plus 3. And that gives us x plus 3 is equal to 0. And then now this becomes your factor. Okay. Or, like I said, just put an x in front and change the sign. That's a -3, so it's now a positive 3. And that's a positive 5, so that's an x minus 5. And then you have x minus 2i and x plus 2i. And those are our factors. So let's look at B. So it's asking us to write that in standard form. So what is the standard form of the polynomial? All right, a little bit of math to do here. Important thing to note is we're going to multiply these factors together. Again, we're going in reverse. So we're going to multiply these together. But what you want to do is you want to make sure you're keeping your i's together when you're multiplying. So you're going to start by multiplying these two, and then you'll multiply these two together, and then afterwards you'll multiply it all together. All right, so let's have a look at that. So since it's already written up here, let's go ahead and just make good use of that. So remember, we're going to multiply this, and then we're going to multiply this, and we'll come back and we'll multiply them together. So let's start with that. So you got x times x, that becomes x squared. X times -5, that becomes -5x. Then you got 3 times x is screen's bouncing around, is 3 times x is a positive 3x, and then 3 times negative 5 is negative 15. And so now that's all together. Now let's multiply the other one. So you have x times x, that becomes x squared. Then you have negative 2i, x times positive 2i, so that becomes a positive 2ix. Then we're going to multiply negative 2i times x, and that becomes a negative 2i x. That's not the same variable. That's why you can't just do anything with that and combine them. All right, so then you got negative 2i times negative 2i. That becomes a positive. Sorry, my screen's kind of bouncing around here. That becomes a positive, not a positive, a negative 4i squared. Let's see if we can erase this and clean that up a little bit. Ooh, kind of took a lot there. Let's bounce that back. We get the point. That's a negative right there. So now we're going to go ahead and combine like terms, if you can, inside the parentheses. So there's no other term that's squared, so that is going to come out by itself. So that's x squared. A negative 5x and a 3x, that comes out as a negative 2x. And then you bring out your negative 15. All right, over here on your green side, you have an x squared there. There's no other squared term, so you bring that out. That is x squared. Then you have a positive and a negative ix, and so those are going to just cancel out. And that leaves you with a negative 4i squared. Now, one thing to note here is an I squared is the same thing as a negative 1. So let's go ahead and do the math on that. That's just something you have to know. So that comes out as negative 4 times a negative 1, x squared. And then that breaks down to, it's pretty much just changing your sign. X squared plus 4. So let's slide this down. X squared minus 2x minus 15. Kind of separate that a little bit. But we still have 2 polynomials left, so we have to continue to multiply that out so we can get to just a standard form polynomial. And so we'll continue with that math. So we have x squared times x squared, that is x to the 4th. Got x squared times 4, that becomes a positive 4x squared. We have 2x, or negative 2x, times an x squared is a negative 2x to the 3rd. And then you got negative 2x times a positive 4. That gives you a negative 8x. Then last but not least, you got negative 15 times nx squared is a negative 15x squared. Then you got a negative 15 times a positive 4, and that becomes a negative 60. So lots of multiplication here. I mean, this was just a larger one. So we had to multiply a bunch of stuff together. So once we multiply all the way out, the last thing we have to do is combine like terms. So I'm scanning across the top. Anything else to the fourth power? No. So I'm going to drop that down. X to the fourth. Scan across the top again. Anything else to the second power? Yes, there is. So I know I'm going to combine this one and this one. So I have a negative 15x and a positive 4x. That's going to become a... Oh, wait. Actually, before we do that, well, let's do it in order since we're putting it in standard form. So that's a 2. We want the next biggest term. So that's a 3. So there's no other 3 up there in the exponent. So we're going to bring that down. It's going to be a negative 2x. In order for it to be in standard form, the exponents have to count down in order. All right, so we drop that down. Now we can deal with our squared terms. So we have a negative 15x squared and a positive 4x. That becomes a negative 11x squared. And then we have minus 8x and then minus 60. And we're done. So just as a recap, all right, so you were provided with zeros, negative 3, 5, and 2i. We said that when you're dealing with imaginary numbers and radicals, they're always going to come in pairs. So that was a positive 2i. That also means we're going to have a negative 2i. It asks us our factors. I gave you the example there. If you need to hear that again, go back and watch it. But the gist of it is, if they're providing you with the factors, you're going to put an x in front and change the sign. So there we had that. So remember to multiply the I terms together and then your other two terms together. But it's important to multiply your i's together. Okay. Once you do that, we got this, and we just multiplied all the way out until we couldn't multiply anymore, and we combined like terms, and then we had our standard form polynomial. Moving along to number 4. Kind of want to skip that one because it's pretty much what we already did in number 3, but I guess I'll go ahead and knock that out too. Because we have one of the zeros or solutions that they provided for you was 0. And so we talked about it in class. When you have a solution that's 0, well, the factor for that is going to be x. So let's go ahead and work this out. So it says, what are the factors of the polynomial? So we know one of them is x, and then we're just doing what we did on the one before. So that's a negative 4, so that's an x plus 4. That's a positive radical 3, so that's an x minus radical 3. That's an ugly 3, so come back on that one. Then you have a negative radical 3, so that's an x plus radical 3, and those are our factors. Now, just like I said a second ago, when you're dealing with radicals and imaginary, you're going to multiply those together. Remember, we're multiplying this all the way out to get a standard form polynomial. So let's go ahead and do that. We'll do this one in green. So x times x is x. What's wrong with my thing here? X squared. X times 4 is 4x, positive 4x. That's good. Let's separate this so we don't get caught up with other stuff. close parentheses. Now we'll do the other one in red. So x times x is x squared. X times radical 3 is a positive x radical 3. And then negative radical 3 times x is a minus x radical 3. And then multiply that, and we have a negative. We're multiplying the numbers under the radical. That gives us a negative radical 9. So now we're looking to see if we can combine like terms. Under there, there's nothing to combine. What about under here? Yes, there is, because that's an x radical 3 and that's an x radical 3. We have a positive one and we have a negative one, and so that is going to cancel out. So now what's left under the parentheses? What is left is x squared, and then you have a negative radical 9, but we know the square root of 9 is 3, so that's the same thing as a minus 3. And so we'll bring this down, x squared plus 4x. And then the last thing we're doing is we're going to just multiply this all the way back out. So x squared times x squared is x to the 4th. Remember, we're multiplying exponents. You're adding them. You're going to add the exponents. And then x squared times negative 3 is negative 3x squared. Then you got a 4x times an x squared. That becomes a positive 4x to the 3rd. And then you have a 4x multiplied by negative 3. That becomes a negative 12x. And then last thing, we're looking to see if we can combine any like terms. We can't. And then we want to make sure that it's in standard form. In order for it to be in standard form, the exponents have to be counting down. That's a 4, that's 2, that's 3, so we know that we have to swap places with those. And so we're going to write x to the 4th plus 4x to the 3rd minus 3x squared minus 12x. And that is our polynomial in standard form. Now let's move along to number 5. All right, we already talked about the difference of 2 cubes. And so here's an easy way to figure out. So if you look there, you notice you have x cubed, or to the 3rd power. And then you also notice that there's only 2 terms. That's a good indicator that it's going to be the difference of two cubes. And so let's look at how to solve this. And so if you want to figure out if it's a difference of 2 cubes, you take the cubed root, or you raise whatever number or whatever to the 1/3 power. And so let's use blue ink here. So you take this, which is an invisible 1, to the cube root. And just like on a square root, to remove the square, the opposite, or no, I'm sorry, for a number squared, the opposite of that is a square root. Okay, and that would eliminate that, and that would be equal to x, because it would eliminate that. Well, the same concept here for a cubed root, or for a cubed term. So you take the cubed root, that eliminates that, and that would make that equivalent to an x. All right, and then so same thing here. So can you take the cubed root of 125, or the same thing is 125 to the 1/3 power? What is that equal to? That's equal to 5. Okay, and so, well, I might as well point this out. So there's an invisible 1 in front of there, in front of the x. And so when you take the cubed root of that, then it would be a 1, and thus it would be a 1x. Take the cubed root of this, or again, the 1/3 power, and that's equal to 5. And so now that I realize that it is, in fact, the difference of two cubes, now I can set up my SOAP. So remember SOAP. I'm going to have a 2-term polynomial and a 3-term. So let's erase some of this out of here. So I notice my sign right there is a negative. SOAP says that your sign inside there is going to stay the same. And so that's a negative. Then my other signs, it says opposite and always positive. So my two signs in between here are going to be the opposite of that. So that is a positive. And then always plus or always positive. And so we'll put a positive over here. Okay, and so we already did all the math a second ago. And so we took the 1/3 power or cubed root of that, and that gave us an x. We took the cubed root or the 1/3 power of 125, and that gave us a 5. Now, how do we get the rest of our information to fill in this polynomial? How we do that is we take the first term over here and we square it. So x times x is x squared. Next, in order to find this term right here, we're going to use both of these numbers, our terms. It's going to be a 5 times an x. That becomes a 5x. And then in order to figure out the last term here, we're going to use the last term over here, and we're going to square it. So 5 squared is 25. Now this is asking us for our zeros or solutions, and so we're going to have to get the solutions out of this, right? So we already know that this one is going to be 5, right? So that one's going to be x is equal to 5. But we still have to figure out what to do with this here in order to get these zeros out of that. And so I know that I'm not going to be able to factor this. Because sometimes when you're doing it and it's pretty easy for you, you just know you can't factor it. And so if that's not the case for you, I told you in class, the quadratic formula always works, and we will provide you with a quadratic formula. And so if you don't know if you can factor it or not, and you're sitting there trying over and over again to factor it and it's just not working out, you can always turn to the quadratic formula. And so let's go ahead and write that quadratic formula for you. So that's opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so we know this is our A, this is our B, and this is our C. And so let's go ahead and plug that into the quadratic formula. So actually, let's just go ahead and write it out. So A is equal to 1, B is equal to 5, and C is equal to 25. So now we're plugging it into the quadratic formula. We have opposite of B is -5, plus or minus radical. Now remember, when you're plugging numbers in, to use parentheses when you're plugging in. So we're plugging in, I'm writing that wrong. So erase that. Let's try that again. Remember, just this first number out here is opposite B. This number inside is just B. And so B is 5 squared minus 4. A is 1, and C is 25. All over 2 times 1. Let's make sure we see this radical on here. Now let's run this math. So you'll still have -5 plus or minus. Now when you do the math underneath the radical, if you punch that all into if you punch this entire thing right here into your calculator, I think you're going to get a domain error or something like that. When that happens, you can try just putting the information there under and see if you get a negative number, and that tells you why you're getting a domain error. Okay, and so what happens here with this one is that stuff underneath the radical turns out to be a -75. And then once you do the math, 2 times 1 is 2. And so we know that you cannot have a negative under the radical. If you do, that means you're dealing with imaginary numbers. And so what do? Let's go ahead and split this. So we got -5 over 2 plus or minus. Now remember, your I is going to come out in front, or I'm sorry, the negative is going to come out in front as an I. That would leave us with a radical 75, okay? And so I'll write that for now. So radical 75. Now using your TI-36X Pro, you're going to punch in radical 75, and that's going to give you a 5 radical 3. And so I'm going to undo that, and I'm going to just change that now. 5I, remember we brought the I out, radical 3 over 2. So now we can do our zeros. And so up here, we know that we set that as 0 and solve. That's going to end up being x is equal to a positive 5. And then we know we should have 3 zeros because right here we had x to the third. And so this is going to serve as our 2 other zeros because there's a plus or minus there. So x is equal to 5, and x is also equal to -5 over 2 plus or minus 5i radical 3 over 2. On to number 6. All right, so we're looking at this. One thing we can do is go ahead and see if we can start factoring this out. First thing to look for is a greatest common factor. We know we can't use number. This is a prime number. So we look at, do they all have variables? Yes, they do. Remember, the lowest exponent wins on a GCF. So we have x squared as our GCF. So what do you have to multiply a 2x to the 4th by in order to get, or I'm sorry, what do you have to multiply x squared by in order to get back to 2x to the 4th? That would be a 2x squared. What do you multiply x squared by to get back to 3x to the 3rd? That would be positive 3x. And then you got to multiply by a -2 to get back to -2x squared. And this is asking for factors, and so I'm assuming I'm going to be able to factor this as a result of that. I guess that's not always a great assumption. But anyways, let's go ahead and try that out. And so, my guys, you know how I like to factor. So I factor a times c, which is 2 times negative 2, and that is a negative 4, and then I take my b term and I automatically put it down there, and that becomes a 3. And then in this spot I figure out two numbers that multiply to give me that and add up to give me that. And I know those numbers are going to be, need my pen. It's going to be a positive 4 and a negative 1. And so what I do next is I write x plus 4, x minus 1. Now because I used a here to multiply there, now I got to factor that back out of there. So I'm going to do that by dividing by that 2. Dividing by that 2. This is called bottoms up. You guys remember I taught you that. Some of you, that is. So now, got to ask yourself, does it simplify? 4 divided by 2. Yes, that does simplify. And so we end up with x, 4 divided by 2 is 2. So it's x plus 2. Does this simplify? No, it does not. And so with bottoms up, if it does not simplify and you have a fraction, you take what's on bottom and you swing it up in front of the x. So it's bottoms up. So when we do that, when we swing that up, we now have 2x minus 1. Now we can't forget about our GCF that we had out there. And so let's set that equal to 0. X squared equals 0 in order to get that square term off of there. We got to take the square root. That's going to end up being x is equal to plus or minus 0, but there is no plus or minus 0. So it's pretty much just going to be x is equal to 0 twice. And so our factors in order to get back to x squared is x times x. So we'll have x as a factor, x as a factor, and then our other two factors are what we already factored out there, are x plus 2 and 2x minus 1. So let's keep it moving to number 7. So this is telling us to find all the indicated zeros, root solutions, or factors. Under this particular problem, it's telling us to list the factors. So the question is, how do we do that? So what we do is we're going to take this entire function right here and we're going to type it in the TI-36X Pro into the table. We'll go into the table, and under the table we'll find where y is equal to 0, and then it'll give you an x value. So out of the calculator, it will give us a x is equal to 2 and x is equal to 3. And so to find our factors, let's go ahead, we pretty much get 2 already because it's, remember, we can just put an x in front of this and change the sign, so it'd be x minus 2 and it'd be x minus 3. But we know there's going to be 3 factors because we have a degree of 3. And so we have to find one more factor. So we're going to use synthetic division in order to do that. So let's start with this first 2 here and go ahead and do our synthetic division. So we have 2. Remember, we're taking these numbers, a 1, a negative 7, 16, and a negative 12. The exponents are counting down, 3, 2, 1, and then 0. So we don't have to have any zeros to fill in the spots. So we have a 1, negative 7, 16, and negative 12. Draw this here. Remember, our remainder is going to be there. So we're going to drop this 1 to start, and then you're multiplying. We just did this a second ago, so I'm going to do it pretty fast. Okay, so 2 times 1, 2, add these, that's a negative 5, multiply 2 and the negative 5, that's a negative 10, add those together, that's a 6, multiply the 2 and the 6, that's a 12, and then you get a factor of our remainder of 0. So now we know we have to use synthetic division once again, so that is 3 out here. Put that there. 1 automatically comes down. 3 times 1 is 3. Add those together, it's a negative 2. 3 times negative 2 is a negative 6. I forgot to put my box. The remainder is 0. So there's now we just figure out what to do next. And so I always say count backwards from the remainder. So that would be x to the 0, x to the first power. Or you lose a degree every time you come down and do the synthetic division. So you were at 3, that took you down to a 2, that took you down to a 1, so it'd be x to the first power, and then count down from there. And so that's a 1x minus 2, so the same thing is x minus 2. And so that is indeed one of our factors. So you have x minus 2. You can go up here, and you see right here, we're using these as our factors. So again, put an x in front of that, change the sign. That will become another x minus 2, and then use the same thing for x equals 3. That becomes x minus 3, and those are your factors. Let's look at number 8. All right, so exact same thing. I'm going to put that in my calculator in the table, and it's going to give me x is equal to negative 2. I'm going to use synthetic division. So negative 2. Is it counting down? Yes, it is. 3, 2, 1. So that's 3 we'll use there. There's a negative 11. We don't need any zeros to fill in gaps. 50. I'm going to do this pretty fast because, guys, this is essentially the same thing. So bring this 3 down. Negative 2 times 3 is negative 6. Add the negative 11 and negative 6 together. That becomes negative 17. Multiply that by the negative 2. That becomes a positive 34. Combine the negative 9 and 34 together. That becomes a 25. 25 times negative 2 is negative 50. And I have a remainder of 0. Now, the calculator only gave us the 1, 0, and so we have to do something to find our other 2 because we have a third degree here, which means there's 2 more because we only have 1. So now we have to do something, quadratic formula, factor, whatever, right? But either way, we got to get to our other 2 factors, or zeros or roots, not factors, but zeros, roots, or solutions. And so let's do what I do here, and we'll count backward, x to the 0, x to the 1, x to the 2. And so that is x squared. That becomes 3x squared minus 17x plus 25. I'm going to use the quadratic formula. Let me go ahead and write that in for you. It's good to have. Opposite b plus or minus square root of b squared minus 4ac all over 2a. So here we have a is equal to 3, b is equal to negative 17, c is equal to 25. So let's start plugging in. Opposite of b is 17 plus or minus square root of b, so negative 17 squared minus 4. A is 3. C is 25. All over 2a, which is 3. So once you run the stuff under the radical in the calculator, you're going to end up with a negative number. Okay, so you'll end up with a 7. That's a different color. Let's switch this out to red. All right, so we got 17 plus or minus, and that'll be radical negative 11, and then 2 times 3 is, let's split these, 6 over 6. Well, we know that you can't leave a negative underneath the radical, so this negative is going to have to come out in front as an I. And so that would equal 17 over 6 does not simplify, so 17 over 6 plus or minus an I, and then radical 11 does not simplify. Radical 11 over 6. And it does not get any simpler than that. So we know we have this as 2 roots because it's plus or minus. And then you have your x is equal to negative 2. And so let's write it down at the bottom. X is equal to negative 2, comma, 17 over 6 plus or minus I radical 11 over 6. You can always pause, rewind, play back if you didn't understand a process, but a great way to learn. Just watch it over and over again until you get it, right? And we are moving. Let's go to number 9. Guys, it's getting redundant now. We're doing the same thing over and over again, but I'm still rocking with you. So let's put it in the calculator, same exact way, in the table. Once we put it in the table, our calculator is going to give us x is equal to negative 2, x is equal to 3. We're finding the solutions are the zeros, so we're doing the exact same thing. We'll take one of our zeros and we'll do synthetic. These are counting down 4, 3, 2, 1, so we don't need any zeros as placeholders. And so we just write 1, negative 1, 1, negative 7, negative 42. So now we do the math. 1 slides down. That 1 times a negative 2 is a negative 2. Combine those together, the negative 1 and the negative 2, and that is a negative 3. Multiply negative 3 times that negative 2. It's a 6. Combine that's a 7. Multiply the 7 by the negative 2, and that's a negative 14. Combine those two up top, and it's a negative 21. Negative 21 times the negative 2 is a positive 42 with a remainder of 0. Okay, so that was our negative 2. We still have another 0, so we take that 0, which is 3, x is equal to 3, and we do the synthetic once again. 1 comes down automatically, or the first term, rather. That becomes 1. 3 times 1 is 3. That's a 0. Multiply that 0 times 3. That's 0. 7 comes down. 3 times 7 is 21. Remember, the last one is always the remainder, and that is a remainder of 0. Count backwards. X to the 0, x to the 1, x to the 2 are squared, and so that is x squared. X, that comes out of there as x squared. You don't have to write a 0x, but that's a positive 7. So now we're looking for 2 more zeros. So, you know what, we can solve this one by square root. And so we'll set that equal to 0. We'll subtract 7. That becomes x squared is equal to negative 7. Square root. Let's bring this up here. That'll leave us with x is equal to plus or minus radical negative 7. But remember, this must come out in front as an I. And so right below that, we'll have x is equal to plus or minus I radical 7, because that does not simplify. So remember, this is a plus and a minus, and so that means it's x is equal to a positive radical 7, our positive I radical 7, and then it's also equal to a negative I radical 7. So that's our 2 other zeros because we needed 4, and so we are done. X is equal to a negative 2, 3, and plus or minus I radical 7. And on to number 10. All right, same stuff, guys. So punch it in your calculator, into the table. The table's going to give you one of the zeros. That 0 is x is equal to negative 4. All right. And then we're doing synthetic division. We know we should have 4 zeros because we have a degree of 4. Okay. Remember, zeros is the same thing as solutions and roots. All right, so let's hop into our synthetic division. This is a big one here, so I'm going to try to save some space. This is counting down 4, 3, 2, 1, so we don't need any placeholders. So, 2, 3, 2, and 100. Hope I have enough space here. This comes down automatically. I'm just doing the math at this point, guys. You already heard me talk it through. It's the same old, same old. And so, counting backwards from the remainder, x to the 0, x to the first, x to the second, x to the third. So that comes out as 2x to the third minus 5x squared minus 10x plus 25. We are still looking for how many? 3 zeros. We have 4 terms. So, guys, we had to keep going with the work. So when we have 4 terms, we know we can factor by grouping. So we're looking for a GCF in the first set of parentheses, and we can pull out an x to the second. Inside the parentheses, we'd have 2x minus 5. And then on the second set of parentheses there, we can pull out a negative 5 as a GCF. And then inside the parentheses, we'd have 2x minus 5. Okay, now, remember when solving by grouping, you should end up with the same thing inside the parentheses. And so we can just leave that as one set of parentheses and then combine the stuff that's outside of the parentheses inside another set of parentheses. And so that's x squared minus 5, and then 2x minus 5. And so now what I'm going to do is I'm going to set, we need the zeros. And so I'm going to set both of these equal to 0 and solve for x, because we can solve this one by square root, and we can just solve this one for x. And so x squared minus 5 is equal to 0. We're going to add 5, add 5. That gives us x squared is equal to 5. Take the square root, and that's going to leave us with x is equal to plus or minus radical 5. On this side, we're going to do the exact same thing. 2x minus 5 is equal to 0. I'm going to add, hey, what's wrong with this thing? Add 5. It's going nuts. So add 5. Add 5. That's 2x is equal to 5. And divide by 2. Divide by 2. X is equal to 5 over 2. And so we have 2 zeros here, a plus and a minus radical 5. We got 5 over 2, and then we have negative 4, so that's all our zeros. And so x, I have to do that in green so it's clear. X is equal to plus or minus radical 5. It's equal to negative 4. And it's equal to 5 over 2. Moving right along. All right, so guys, yes, finally a super easy one. So again, punch all this into your table and go through and look for the values where y is equal to 0, and that's going to tell you your x-intercepts or your zeros. And so when you do that, luckily on this one, it shows you that x is equal to negative 3, x is equal to negative 2, x is equal to 1, and x is equal to 2. It gives you 4 zeros right here. Well, guess what? All we need is 4 zeros. So now all we got to do is just convert this into a factor. And so again, you just put an x in front, change the sign. That's a negative 3, so that becomes a positive 3. X plus 2, x minus 1, and x minus 2. Boom, done. Let's go. All right, so that was super easy. Whenever the calculator gives you all your zeros, well, one, you either have your zeros, and if you need the factors, you just go ahead and change them into factors. And then the last one, number 12, guys. This video is getting kind of long, so hopefully you found it useful. Take your function, punch it in the calculator. It's going to give you some zeros. It's going to give you x is equal to -1 and x is equal to 7. Same exact thing. We're going to do some synthetic division. So let's start with our -1. -1, is it counting down? 4, 3, 2, 1, 0. Yes, it is. So we don't need any placeholders. So we're going to put the 1, -6, 3, -24, and -28. Going to have our remainder there. Remember, first number drops. And we're doing it quick, guys, because, once again, it's redundant. So, -1, it's -7. -28, -28 times 1 is a +28. That's what we're looking for. It's a 0. All right. We have another 0 that we're working with. So let's do 7 here. One drops. So counting backwards, x to the 0. Next one is x to 1, and then x to the second. So that comes out as x squared plus 4. We can solve this one by square root, so we'll set that equal to 0. We start solving, so -4 minus 4 x squared is equal to, whoa, we're going to take the square root, let's go up here, x is equal to plus or minus square root of -4. Remember, the I has to come out front in place of the negative. That becomes x is equal to plus or minus I radical 4. You can't just leave radical 4 there because the square root of 4 is 2, and so you'll end up with, remember, last thing to remember here is it's real before imaginary. And so it'll be plus or minus 2i, because the square root of 4 is 2. All right. So we have 2 zeros here, a plus 2i and a negative 2i, and then you have x is equal to -1 and x is equal to 7, and thus our zeros are x is equal to -1, 7, and plus or minus 2i. All right, that video was long enough. Hopefully it helped. Pause, rewind, watch again, and study, man.